Welcome to part 2 of the lecture series on addition and subtraction of real numbers. In this section, we will study addition and subtraction of fractions. In the first part of this lecture series, we covered addition and subtraction of integers. We will start with addition of fractions. It is important to remember that as long as the denominators are the same, we can add fractions. When there are like denominators, we just add the numerators, and then we carry over the denominator. For instance, 1/3 plus 4/3. To add these two fractions, we add the numerators and carry over the denominator, giving us 5/3. When adding fractions with unlike denominators, we must first find a common denominator and then add the numerators. There is a simple process for finding like denominators to add two fractions. In describing this process, we will let variables represent numbers. Let A, B, C, and D be non-zero integers. Then we can add the two fractions A over B plus C over D by first finding a common denominator. In order to start this process, we will multiply the first fraction by D over D. Notice that we are multiplying by the denominator of the second fraction over itself, but any number over itself equals 1. So it's like multiplying A over B times 1. We will do the same for the second fraction, but this time we will multiply it times B over B. When we multiply the numerators and multiply the denominators of these two products, we get AD over BD plus CB over DB. Now BD and DB are the same value. Multiplication is commutative. That means we can switch the numbers around and multiply in different orders, but you will still get the same value. Now that we have like denominators, we must add the numerators and carry over the common denominator. We will use this process in an example. Determine the sum of 6 over 4 plus 8 over 3 using the method described above. We will reduce the answer to lowest terms. Starting with 6 over 4 plus 8 over 3, and using the process above, we will multiply the first fraction by 3 over 3, and we will multiply the second fraction by 4 over 4. Now multiplying the numerators and multiplying the denominators, we get 18 over 12 plus 32 over 12. We can now add the numerators and carry over the common denominator. When we add the numerator and carry over the common denominator, we get the fraction 50 over 12. This fraction can be reduced. From a previous section, we learned how to reduce fractions. The number 2 will divide evenly into both 50 and 12, so we can write 50 as 25 times 2, and we can write 12 as 6 times 2. We will cancel the 2's and get our final answer, 25 over 6. We will now look at adding fractions using the least common multiple. Another approach to adding fractions is to find what is known as the least common multiple of the denominators. The definition of the least common multiple, which is abbreviated LCM, of two numbers, is the smallest natural number that is a multiple of both numbers. A multiple is a number that can be divided by another number without a remainder. We will look at examples. Determine the sum of the fractions by finding the LCM of the denominators first. If necessary, reduce answers to lowest terms. For our first one, we will add 1 over 6 plus 3 over 4. We need to have a common denominator before we can add two fractions. In this case, we could easily use the process that we used in the previous slide. but we are asked to use the LCM, which is the least common multiple. Our goal then is to find the smallest number that both 6 and 4 will divide into evenly. The smallest number is 12. Therefore, the least common multiple of the denominators is 12. So in order to add these two fractions, we must determine a number that we multiply over itself times the first fraction in order to get 12 in the denominator. That number would be 2 over 2, which is the same thing as multiplying by 1. So we will multiply 1 over 6 by 2 over 2. For the next fraction, we multiply a number over itself times 3/4 in order to get a 12 in the denominator. That number will be 3 over 3. When we multiply the numerators and multiply the denominators of both products, we get 2 over 12 plus 9 over 12. Now that we have like denominators, all we have to do in order to add these two fractions is add the numerators and carry over the denominator, giving us the final answer, 11 over 12. This fraction is already in lowest terms. For our second one, we are adding 3 fractions. In this case, again, we must find the least common multiple of the denominators. The smallest number that 4, 6, and 8 will go into evenly is 24. Therefore, the least common multiple of the denominators is 24. So in order to add these 3 fractions, we need a common denominator of 24. So we will multiply the first fraction by 6 over 6. We will multiply the second fraction by 4 over 4. And we will multiply the third fraction by 3 over 3. Multiplying the numerators and multiplying the denominators of all 3 products gives us 18 over 24 plus 20 over 24 plus 12 over 24. Now we can add the numerators and carry over the common denominator. We get 50 over 24. This is our answer, but it is not in lowest terms. In order to put this answer in lowest terms, we reduce the fraction. We can see that 2 will divide evenly into both 50 and 24. So we can write 50 as 25 times 2, and we can write 24 as 12 times 2. Canceling the 2's gives us the reduced fraction 25 over 12 as our final sum. We will now look at adding fractions with negative add-ins. From part 1 of this series, we added integers with negative add-ins. The rules that applied for adding integers with negative add-ins will apply to all real numbers, including fractions. We will look at 2 examples. Determine the sum of the fractions. For our first example, notice that we are adding 2 negative fractions. One thing I would like to point out that is important is that when you have a negative in front of a fraction, you could move the negative in front of the numerator, or you can move the negative in front of the denominator, and it will not change the value of the fraction. So I'm going to start with moving the negative in front of the numerators of each fraction. Now, remember, in order to add 2 fractions, you must have like denominators. So the first thing we must do is multiply these 2 fractions by something that will give us the same denominator in each fraction. Notice that the LCM, or the least common multiple, is 15. So we will multiply the first fraction by 5 over 5, and we will multiply the second fraction by 3 over 3. Now we must multiply the numerators and multiply the denominators of both products. Keep in mind, when you multiply a negative times a positive number, you get a negative result. So when we multiply the numerators and multiply the denominators here, we get negative 5 over 15 plus negative 6 over 15. Now this is where adding the negative add-ins comes into play. Since we have like denominators, we can add the numerators. But both of these numbers are negative numbers, so they are of like sign. When you have like signs, you add the absolute value of the numbers and then keep the common sign that they have. When I add 5 and 6, I get 11, but I keep the sign, which gives me negative 11 over 15. Another thing I would like to point out is that this answer could be written with the negative in front of the fraction. Remember, the location of the negative does not change the value of the fraction. For our second example, we are adding fractions with unlike signs. The first thing I want to do with the first fraction, I want to put the negative in front of the numerator. Again, we are still adding fractions with unlike signs. We need a common denominator. I will multiply the first fraction by 9 over 9, and I will multiply the second fraction by 8 over 8. When I multiply the numerators and multiply the denominators of these two products, we get negative 27 over 72 plus 16 over 72. Now we can add the numerators, carry over the common denominator. Recall from part 1 of this series that when you add two numbers with unlike signs, you subtract the smaller absolute value from the larger absolute value. That would give us 27 minus 16, which gives us 11. Then we keep the sign of the larger number, which is negative. Therefore, when we add negative 27 plus 16, we get negative 11 and carry the common denominator. But remember, this may also be written with the negative in front of the fraction. Consider a more complex example. If 4 over 3 minus 6 over 4 plus 1 over 5 plus 2 over 4 is calculated and the answer reduced to lowest terms, what is the denominator of the resulting fraction? Notice that they are not asking us for a fraction as an answer. They're asking for only the denominator of the fraction. This is a type of problem you would likely see on an ACT test or a compass test. The compass test is a test that you would take to test out of a developmental course. There are two ways we can approach this problem. We could remove the parentheses since they are separated by a plus sign and perform each operation from left to right. In this case, we would be following the order of operations without the parentheses. We will actually discuss order of operations in a later section, and we will consider the same example using another approach. For now, we will take the difference in the first set of parentheses, and then take the sum in the second set of parentheses, and then add the results. First of all, notice we can write the difference in terms of a sum. So we must apply the rules for adding numbers with different signs. In the first set of parentheses, we will multiply the first fraction by 4 over 4, and we will multiply the second fraction by 3 over 3. In the second set of parentheses, we will multiply the first fraction by 4 over 4, and we will multiply the second fraction by 5 over 5. Now, when we multiply the numerators and multiply the denominators of all four products, we get 16 over 12 plus negative 18 over 12 plus 4 over 20 plus 10 over 20. Now, adding the numerators in each set of parentheses and carrying the common denominators gives us negative 2 over 12 plus 14 over 20. In order to add these two fractions, we must find a common denominator. Notice that the smallest number that both 12 and 20 will go into evenly, or the LCM, is 60. So we will multiply the first fraction by 5 over 5 and the second fraction by 3 over 3. Multiplying the numerators and multiplying the denominators of the products gives us negative 10 over 60 plus 42 over 60. Adding the numerators and carrying the like denominator gives us 32 over 60. Reducing this fraction gives us 8 over 15. The question is, what is the denominator of the resulting fraction? And our answer would be 15.